Okay, so for this video, the question is that there is a 30-kilogram crate at rest on a 15-degree incline, and a strong wind starts, and it suddenly starts pushing horizontally on the crate with 200 newtons of force, and there is no friction on the ramp. And we need to find the velocity of the crate after it moves 5 meters up the ramp. And we're supposed to use energy and work and not kinematics. So first of all, we're going to want to find the component of the force that is pushing the crate along the incline of the ramp. So we can draw a right triangle here with respect to the crate coordinate system, and we can see that the vectors point downward into the ramp and upwards along the ramp, and this angle right here is 15 degrees. With that information, we can do some trig and see that cosine of 15 is equal to the adjacent over hypotenuse, which is 200. Put that into your calculator and get a force of 193.185 newtons going along the ramp. But this isn't quite enough because gravity exists. So now we need to find the force of gravity that is pushing backwards against the force of the wind. Same, we have to make a triangle. And so we see here that this hypotenuse right there is the force of gravity, mg, and these two components are its components. And we can see that the opposite one over here is pushing against the force of the wind because it's pushing down the ramp. So we do more trig. This time we use sine, and sine of opposite over hypotenuse. Sine of 15 is equal to opposite over hypotenuse. Put that into your calculator and you get the opposing force of 76.09. Subtract those two because Newton's second law, sum of all the forces. And get a net force of 117.029 newtons upward the ramp. And we know that work is equal to force times distance, and work is the units of work are joules. And we know that energy is equal to 1/2 mv squared, and those units are also in joules. So to find the work, we simply take the force that is going up along the ramp and multiply it by the distance, which is 5 meters. That's given in the problem. And that gives us a work of 185.46 joules. Let me just put that in there real quick. And if work is in joules and energy is in joules, and we want to find the velocity, we can set the energy equal to 585, kinetic energy to be specific, to be 585.46 joules. Do a bit of algebra, and we end up with a velocity of 6.247 meters per second up the ramp. And that is after the crate has traveled 5 meters up with the wind blowing against it, or against the back of it.